So we talked last video about some very simple circuits, and we want to look at just kind of two different types of circuits now that are a little bit more complicated. So if we have our circuit, let's say we have our battery here. Okay, there's our positive and negative end going off here. And last time we just had, our wire across and then a resistor and down, and that was our simple circuit. Well, what if I have a circuit where, let's say I add in two more resistors, just like this. Okay, now it's not quite as simple of a circuit we had before because now we have three different resistors within our circuit. This type of circuit is called a parallel circuit. A parallel circuit because all three of my resistors are here in parallel with each other, right? They're kind of parallel lines to each other, if you will. The other probably more distinguishing characteristic of a parallel circuit is that each resistor is independently connected to the battery, right? If I removed, let's say, these two resistors, the both ends of that resistor are still connected to the battery, and that means it would still function properly, right? If I remove this one and this one, my middle one would still have that complete loop, right? So each end, even though they're kind of attached to each other here, each end is attached to the battery itself, and my resistors are parallel to each other across that circuit. Compare that maybe to a series circuit over here, okay, where I have my battery, and let's say I'd have a resistor here, and on this side. And that's what a series circuit would look like. So we have each resistor sort of connected to each other all the way around the loop. So if I took this resistor out of my circuit, all of a sudden I have a gap there, and my circuit would no longer function. So with a series circuit, it's one right after the other, and if I remove one, I stop my circuit from working. I get rid of that complete loop. Whereas my parallel side, right, if I get rid of one, since everything's sort of connected to the battery on its own, each end connected to the positive and negative end, it would still work. I wouldn't have any gaps if I took one out, and the other two would still function properly. So those are kind of the defining characteristics of a parallel and a series circuit at a very basic level. You need to be able to look at a circuit diagram and figure out for yourself whether it is a parallel circuit or a series circuit. So let's look at a series circuit real quick. And what we want to be able to calculate, say, is the current moving through a series circuit. Well, in order to do that, I need to calculate the total resistance in a series circuit. So let's say I have my 9-volt battery here, and then it's connected here to a 1 ohm resistor, and then a 3 ohm resistor, and lastly a 5 ohm resistor. And we want to calculate what's the current running through our circuit. Well, normally we'd use Ohm's law, right, which is V over R, voltage over resistance. But we have several different resistors, so which one would you use for the bottom? Well, we have to calculate a total resistance in the circuit. Our total resistance in a series circuit is just resistor 1 plus resistor 2 plus resistor 3, so on and so forth if we have more than 3 resistors. So my current flowing through this particular circuit would be my voltage, 9 volts, divided by my total resistance, which would be 1 ohm plus 3 ohms plus 5 ohms, which is 9 ohms total. So 9 volts divided by 9 ohms would give me a 1 amp current moving through this circuit. Now, a simple way to double check yourself here is that at each resistor, we have what we call a voltage drop. In other words, my voltage drops from 9 volts to something else at each resistor. Well, remember, this is a potential difference, so it's like having 9 on this side and 0 on this side. So my 9 should get used up by all these resistors. So if I did each of these individually with a 1 amp current, I should still get 9 volts. Okay, kind of simple in this example since I ended up with 9 volts and 9 ohms, but let's go ahead and go through it. So if I have a 1 amp current moving through a 1 ohm resistor, that's a 1 volt drop. So now I'd be at 8 volts. If I have a 3 ohm with a 1 amp current, then that would be a 3 volt drop. So now I've used 4 of my 9, so I have 5 left. And a 5 ohm with a 1 amp current would be 5 volts. So 1, 3, and 5 adds up to my total of 9 volts. And this should always happen, regardless of what current you have, regardless of what your voltage is that's powering the circuit. If you add up the voltages at each individual resistor, you should end up with your overall voltage again. So now let's look at total resistance in a parallel circuit. So let's take my 9-volt battery again, and this time wire it up to a parallel circuit. So something like that. And let's bring back our 1 ohm, 3 ohm, and 5 ohm resistors. And we want to look at how resistance adds up when we're in a parallel circuit. Now it's a little bit different than in series, because in series, remember, we had voltage drops across each resistor, but we had the same current moving through. The opposite's going to be the case here. Okay, I'm going to have the same voltage across each of these resistors because they're each connected to each end of the battery. They're going to be the total of 9 volts across. So what I am going to have is, instead of voltage drops, I'm going to have current drops. So I'm going to have three different currents running through each of those resistors. So I1, I2, and I3. So the way we would get total resistance in something like this is slightly different. So instead of just adding them up, we're going to say 1 over our total resistance is equal to 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3, and so on and so forth. So let's go ahead and calculate the total resistance in this circuit here. So if I have 1 over R total equals 1 over R1, which is 1 ohm, plus 1 over 3 ohms, plus 1 over 5 ohms. And now all of a sudden it's not such a straightforward problem anymore, because we have to worry about things like common denominators and things like that. So if we did that, or took a shortcut and put it in our calculators, we should get that 1 over our total resistance equals 1.533, and that would be 1 over ohms in this case. And then our total, to get that, we take 1 divided by that, which gives us 0.65 ohms as our total resistance. And then if you're going to calculate a total current in this wire, right, we would take our 9 volts divided by 0.65 ohms, and we would get 13.8 amps. Now notice real quick how much bigger of a number this is than the current that we got in our last circuit. Our last series circuit, we got a 1 amp current with the same resistors. This time we got a 13.8 amp current for the same resistors, and that's just switching them up from a series to a parallel circuit. Now if we calculate all of our individual currents here at our resistors, let's see if they add up to our total. So I1 would be my 9 volts divided by my 1 ohm resistor, so there would be 9 amps. I2 would be 9 volts divided by my 3 ohms, so 3 amps. And I3 would be my 9 volts divided by 5 ohms, which equals 1.8 amps. And notice if you add all of those together, the current at each individual resistor, we get our total again of 13.8 amps. So there's another good way to double check yourself with these circuits.